Hi, I'm Runji, welcome. In this video, we'll explore a new Wi-Fi 8 feature called UEQM for MIMO transmission. Over the next few minutes, I will walk you through 3 live demos. First, we'll generate a Wi-Fi 8 UEQM MIMO signal using Keysight's embedded WLAN app. Next, we'll measure that signal with the X-apps software. Finally, we'll analyze the same signal with 89600 VSA software. In traditional WLAN MIMO, all spatial streams use the same modulation. That means if one stream has poor SNR, everything slows down. Wi-Fi 8 changed that with unequal modulation across streams, boosting throughput when SNR varies. So, what does UEQM look like in the spec? Right now, it supports 2 or 4 spatial streams. Let's use 4 as example here. There are 4 UEQM patterns. In pattern 0, if S is 256 QAM and S-1 means one order lower. So, the first 3 streams use 256 QAM and the last one drops to 64 QAM. For today's demo, we'll use a 2x2 MIMO case. We've got 80 MHz split across 4 users. Each gets 20 MHz. The last user applies UEQM across these 2 spatial streams. Now let's dive into the first part, how to generate this MIMO signal. On the VXGC screen, click the cube icon at the top bar and select WLAN from the app list. By default, you will see one spatial stream. To enable multiple streams, tap MIMO button here and select the number of streams. I'll choose 2 for this demo. Next, head to the basic page. Set the radio format to 11BN, that's Wi-Fi 8. Choose PPDU format as MU PPDU. Then set the bandwidth to 80 MHz. Now configure users under the Carrier tab. Important thing here, remember to set number of transmit chains to 2. Disable compression mode in UHR SIG page so we can manually control resource allocation. Go into RU arrangement page and adjust the allocation index for the first band so it matches the others. On the summary page, confirm each RU is 242 turns, perfect for 20 MHz per user. However, the number of spatial streams may not be correct yet. To fix that, open RU band 1 and confirm the spatial mapping matrix is correct in my setup. Then go to User Setup. Set number of spatial streams to 2. Set station ID to 4A3. Set MCS index here to 17. And for the first user, we'll leave UEQM off. For the other users, I will record a Signal Studio file I created earlier to save time. Once loaded, you will see all user settings are automatically populated. User 2, MCS index 19, station ID 743. User 3, MCX index 20, station ID 1021. User 4, station ID 1281, MCS index 8, UEQM on, Unequal mode, pattern 1. Back in the summary page here, everything looks aligned and ready to go. Let's generate the waveform. Go to the waveform page and click Generate. In the bottom window here, you will see the generated waveform display for each antenna. Back on the home page, you will see 2 generated waveforms playing on each channel. Set your IF frequency, IF power, and enable the IF port for each channel. The signal is now ready to output. The embedded WLAN application also supports exporting waveforms. Let's export this demo signal for further use. Click Export. Give it a name. and confirm. In your defined repository, you will find 2 exported waveform files. There use the name you provided plus an ANT suffix to indicate the antenna channel here. Now let's move on to part 2, analyzing the signal with X-apps WLAN MIMO Measurement. For this demo, I'm using modular instruments. To enable MIMO measurement, first make sure the MIMO function is turned on onto this repository path. Once that's done, launch the modular TRX software. Here, I'm using slot 3 and slot 9. After a short initialization, you will see X-apps running successfully on both slots. To analyze a Wi-Fi 8 MIMO signal, confirm that your X-apps installation includes the MIMO license and the Wi-Fi 8 license here. Now, in the main window, select WLAN mode, then choose MIMO Modulation Analysis Measurement. Inside X-apps MIMO Measurement, first let's load the exported MIMO waveforms into the ARP. Set the VXT SG source frequency, IF power, then enable the source IF port. Under source sync, set 2x2 MIMO mode, assign slot 3 as primary and slot 9 as secondary, turn on sync settings, and press sync start. Next, configure the VXT SA MIMO settings. Go to My Setup. Under Global tab, click Remote Analyzer Config page. In the pop-up page, enter slot 9's IP address, add it to the list, select it, verify connectivity, and activate the analyzer. After that, set the radio format to 11BN and the bandwidth to 80 MHz. Once everything synced, X-apps auto-detects the signal and demodulates it. From the constellation diagrams, you can confirm that stream 1 is 256 QAM, stream 2 is 16 QAM. Let's switch to basic info view for detailed decoding. The signal is decoded as 802.11bn UHR MUPPD format, downlink 80 MHz bandwidth. In the user information summary view here, X-apps provides detailed decoding information for each user, such as resource allocation, MCS index, station ID, and the UEQM pattern. Finally, X-apps WLAN MIMO Measurement also lets you export IQ recording data. Let's export this as a VSA format file for the next part of the demo. Now let's jump into the final part, analysis the recording data with VSA 2026. In the latest release, head to My Setup. Then under wireless connectivity, you will notice 802.11bn has been added here. Open WLAN mode properties. 5 new Wi-Fi 8 radio formats are available in preset mode. For this demo, I've selected MUPPDU, enable multi-user mode, and turned on 2 measurement channels. VSA automatically detects settings from the thick decode, super convenient. Click the block icon to view the block diagram for a clear overview of your setup. VSA delivers comprehensive MIMO demodulation results here. From the constellation diagrams, stream 1 is 256 QAM, stream 2 is 16 QAM. In the users table, you will see detailed decoding information for each user, MCS index, station ID, and UEQM pattern, all matching our setup. That's it. To learn more and get a free trial, visit us at this website. Thanks for watching.